Okay, part 2 of our linear programming problem. I got as far as putting in the, or going through and doing the inequalities of the two equations, and I like to start with graphing, try and give myself an idea about what I'm looking at. The first equation is y is equal to negative 2x plus 15, and I've already got a y-intercept over here of 15. So let's go through and figure out how does it go down negative 2x. So this thing is going to drop 2 for every, or rise over run. My slope is negative 2, so I'm going to go down 2. And in this case, I'm going to take advantage of my scale. I'm going to put in here a scale on the bottom so that I can keep kind of a 1-to-1. That's 5, and that's 10. And I can always go back through and change it. And in this case, I can go down 2 units. Well, those units are just 5 each, but it's down 2 of the same thing and over 1 of the same thing. So my next point that I'm going to choose is going to be right here. I could have counted over -2. I could have counted over a positive 1. I've just chosen to do it this way. So I'm going to get out my straight edge and put a point right here. Can't be in negative territory. It went a little bit over. My other equation is y is less than or equal to negative 1/2 x plus 6. That little blue line off to the side was just a flag from our last video. So negative 1/2 x. So it goes down 1 and then over 2 for every, I mean, that's my slope, is down 1 would be negative 1 and over positive 2. So if this number right here is 6, then, and I'm using a unit of being 5, if I just want to go down 1 amount and then over 2 amounts that are the same, well then there's my second point for that particular one. And if you're getting lost in what I'm talking about, this is just slope. I could have put in here individual marks for each one of these and counted down 1, down 2, and then over 1, or excuse me, this is negative 1/2, down 1, and then over 2, and I'm going to end up in the exact same place. This is just again, it's kind of the way that I see it. So let me put my point back. It should be right there. And get out my straight edge. And I'm going to give myself, whoops. Well, I went a little bit past it, but there we go. You get the idea. Okay. So that's where everything is. And let me just give you a heads up. You really need to know what these points are. These are called critical points, where things intersect. You know what? I'm getting a little bit ahead of myself, so let me, whoops, let's put that back. Let me just change that for 1 second. There we go. We're going to erase it. All right. So the idea now is let's put in our shading. Y'all like to talk about that. Y is less than or equal to negative 2x plus 15. That's this one. How do I know? Well, the 15 is up above, so this is y is less than negative 2x plus 15. And this one is going to be my opposite, or the other equation. Y is less than or equal to negative 1/2 x plus 6. Okay, so my feasible region for each one of these equations is going to be wherever y is indeed less than. And an old trick is just to pick a point that is very obviously in the region and see if the equation works. Well, right here I can look and see, you know what? 0.11 is very obviously on that side of the line for both of these equations. So I'm going to test 1 and 1 as my x and my y for each one of these and see if the equation works. So a little bit of writing over here to the side. I said we're going to test 1, 1. So my test point. So I'm going to look at this very first equation. Y is less than or equal to negative 2x plus 15. Let's put in 1 for y and 1 in for x and see if this equation still works. So this is a question mark, is 1 less than or equal to negative 2 times 1, that's negative 2, plus 15. Well, I'm doing the math in my head, that's just 13. So is indeed 13, let's get my pen back, is 13 greater than or less than 1? Well, yes it is. So I know that 1, 1 works. So I'm going to go back to my graph and say, okay, for that very first one, everything in this region will work. That's my feasible region for the first equation. So let's go through and run the test point for my second equation. Second equation is y is less than or equal to negative 1/2 x plus 6. And if I put 1 in here, is 1 less than or equal to 1/2 of 1 plus 6? Is 1 less than or equal to negative 1/2 times 1, that's negative 1/2. If I add 6 to that, that's going to be 5.5. And yes, indeed, 5.5 is greater than or equal to 1, or 1 is less than or equal to 5.5, whichever way you see it. So I know that 1, 1 works for that particular test point, and I realize now that I have a feasible region. Let's change the color a little bit. I now have a feasible region for my second equation that will be everything under, let's make that bigger. There we go. Everything under that line. So this is now my feasible region. This thing that I am about to circle, or not circle, but I'm going to put into a light red tint, this region works. Every point within that region works for both equations. There we go. Everything inside there. So if I pick any point on the lines that are dictated by the region, remember I can't have negatives, so there's nothing over here. Everything within that region will work. So now I can go back to my conversation with you real quickly about looking for what are known as critical points. And the critical points that I talk about are the points where there is some kind of an intersection of all of my constraints. Another word for constraints would be limitations. I am limited. I can't have negative jackets. So we've got this line running down here. And I can't have, I can't have, negative, which one is Y? Yeah, Y is jackets. I can't have on X negative pants. And I don't have any more sewing time or cutting time. So I am truly limited by those lines. So anything within that region will work. The question that you have to be asking yourself at this point is, what are those points? Well, this one's pretty obvious. That one's 0, 0. This one's also pretty obvious because we found it with the other y-intercept, and this is 0, 6. So it's pretty obvious to find those two. But what might be that point? What might be that point? Well, that is the x-intercept for this equation right there. And in order to find that out, that point has to exist where x is 0. So let's make x 0. So what is, that's why I'm putting equals, what is y when x is 0? Well, when x is 0, negative 2 times 0 is just, and I just realized I made a mistake because I'm talking about where x is 0. I got ahead of myself. Sorry about that, guys. See, even your math teacher can make mistakes sometimes. All right, so let's go through and let's just take out this equation, because that's not right. What I'm saying here is that y is equal to 0 at that particular point. So if y is 0, then what is x? Negative 2 of x plus 15. There we go. So I can add negative 2x to both sides. 2x is equal to 15. Divide everything by 2. That's x is 7 1/2. So this would be the point 7 1/2, or 7.5, comma, 0. That's my y. Now, the one that's going to probably give you some measure of trouble is going through and looking for what is the intersection of those two lines. And for some reason, I can't erase that other equation, so we're just going to leave it. What is that point? Don't know. Well, the intersection of that point is going to be the one x value and y value that will let that equation and that equation work. And even though they're inequalities, on the line, it's where y equals negative 2x plus 15 and y equals negative 1/2 x plus 6. So let's change both of these equations to be y equals negative 2x plus 15 and y is equal to negative 1/2 x plus 6. Because the x values for both of these equations and the y values for both of those equations will work at that point. So I need to know what that x, y value is. And the easiest way to do it is solving for a system of equalities. At that point, the y's are the same and the x's are the same. So if these two y values are the same, then I can just say, well, therefore, if the two y's are the same, then those two equations are the same. Negative 2x plus 15 is equal to negative 1/2 x plus 6. And now solving, I can find out that x is, well, I don't know, let's find out what x is. I can't do that in my head. That's a lot of math. You thinking the same thing? Negative 2x plus 15 is equal to negative 1/2 x plus 6. So now we finally get to do a little bit of math. So I'm going to add 1/2 x to both sides. And I'm going to subtract 15 from both sides. Let's see what all this gives me. Negative 1/2 x plus 1/2 x, that's 0. Positive 15 minus 15, that's 0. The equal stays there. Negative 2x plus 1/2, that's going to be negative 3/2 x is equal to, let's see, negative 15, and I add 6 to that, that's going to give me a negative 9. So at this point, I've got some math I need to do. I can multiply both sides times negative 2/3. And again, some of y'all will reach for a calculator, but I like doing it this way. And I chose that because negative 3/2 plus, or times negative 2/3 gives me 1. So x equals whatever this is. A negative times a negative gives me a positive. 9 times 2, that's 18. That could be 9 over 1. 1 times 3 is 3. That's x equals 6. So I found my point, my xy coordinate. My x is going to be 6. And this is an awful mess, but I'm just going to keep it right on chugging. My x is going to be 6. So that point is going to be 6. And then what's y? Oh gosh, you mean I have to do more math? Jeez. Okay. If x is going to be 6, then I can pick either one of these statements and see what the y value is. So let's just plug 6 in here. What happens when 6 is my x? So when negative 2 times 6, that's negative 12, and I add 15 to it, then y equals 3. So 6, 3. Okay, we're going to finish up this problem in part 3. That's coming up in a minute.